So hello everybody, this video is specifically for Nate and Leslie because they were not in class today, and all the rest of the students I have in subsequent years. It's about combinations and how combinations are different from permutations, specifically in the formula and in what they actually count. The first thing we need to know are the three characteristics of a combination. First of all, the items are all selected from the same group. No item is selected more than once. That means no repetition. And the order of the items makes no difference. And this is probably the key fact right here, that the order of items makes no difference. And why is that the case? It's the case, for instance, if we're selecting officers from a club, from a group of 10 students. When you have 10 students and you're selecting a president, vice president, and treasurer, let's say, well, whoever has the most votes is president, second most vice president, third most treasurer. However, what if you're just making a committee? If you make a committee and it has 3 people, you might elect the same 3 people, but if you switch their orders, it's not going to change who's on the committee, where it might actually change what their office is. So committee counting is an idea that is a combination. It's a very practical example. Whereas officer counting, where you're selecting the same number of people for those officers, that would be different and order would matter, because if you were selected first, you could be the president, or last, the treasurer. So the first problems that you have to do are deciding whether something is a combination or a permutation. You have 4 problems in your textbook on page 625. Problem numbers 1 through 4, and I'm going to assign you a couple of those, but let's do number 1 as an example. And the problem says a researcher needs 6 people to test the effectiveness of a drug. If 13 people have volunteered for the test, in how many ways can the 6 people be selected? So the question is, you have 13 people and you want to choose 6, and the question is order important when I choose those 6? Both Bobby and Mary and Susie and Willie and Nathan and June are all those 6 people. Does it matter what order they're chosen in, or are all 6 of them going to be a part of the experimental drug? And the answer is order doesn't matter here. Therefore, this is a combination. So let's go to problem number 3. On problem number 3, it says how many different 4-letter passwords can be formed from the letters A, B, C, D, E, F, G. So how many 4-letter passwords? If you don't allow for repetition. So 4-letter password, well, suppose I have A, B, C, D, that's a password. And based on how passwords work, if I put B, A, C, D, just switch 2 of the letters, that's a completely different password. So the order does matter here, and therefore this one is a permutation. So that's the first problem types you have to do, and I'll assign you a couple of those. The next problem type you have to do is, what does the formula N C choose R mean? Well, this is a combination of N things chosen R at a time. And in factorials, that's N factorial divided by N minus R factorial times R factorial. Well, as you can see, if I were to erase the R factorial, then this is just the permutation formula. So a combination is really a permutation divided by the number of orders that you want to eliminate. And that's why you have the extra r factorial. So how does this work in the formula? Well, if we had something like 10 combination 3 at a time, that would be 10 factorial over 10 minus 3 factorial times 3 factorial. And as you can see, if you simplify that, it's 10 factorial over 7 factorial times 3 factorial. And so if you look really closely, you will notice that the 7 and the 3 have to add to 10. And so you can always get those numbers from this 3 and subtracting it from 10. So you can actually, in some sense, skip this step and just write the combination in this way, and that'll allow you to go a little quicker. Well, let's finish the problem and simplify it. 10 factorial is 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. And 7 factorial is 7, 6, 5, 4, 3, 2, 1. And then 3 factorial is 3, 2, 1. And what you can see is that the 7, 6, 5, 4, 3, 2, 1, the 7 factorial, cancels with the 10 factorial and leaves you just 10 times 9 times 8 over 3 times 2 times 1. Thus you can see all we have to do to finish this problem is cancel the 3 with the 9 and leave a 3, and cancel the 2 with the 8 and leave a 4. So this is really 10 times 3 times 4, or 120. And that's how you do combinations. On the next slide, I want to show you a couple of different options that can happen with combinations. And so I have a couple of problems here completely worked out. And what I want you to do is I want you to look at them really briefly. I have a combination of 10 choose 9 and a combination of 10 choose 1. And when I write them out in formula, as you can see, the denominator here is 1 factorial 9 factorial, and the denominator here is 9 factorial 1 factorial. So the 9 factorials will completely cancel with the 9, 8, 7, 6, 5, 4, 3, 2, 1 and the 10 factorial. So we are just left with 10 over 1 factorial in both cases, which is 10 over 1, or 10. So this is kind of a not a shortcut, but a different way to write out an individual number. Write it as 1 less, or the combination of the number choose only 1. In the same way, if we choose 0 or we choose all 10, what you will see in this case is we get 10 factorial over 10 factorial 0 factorial. And down here we get the same thing based on how we write the combinations. Well, both of those are therefore, because the 10 factorials cancel, they're equal to 1 over 0 factorial. And since 0 factorial is 1, it's 1 over 1, or 1. So this shows us kind of the quick cases for how to do some simple problems once we write them out. So you can use the calculator, and the n factorial, or excuse me, a combination of n things chosen r at a time, is under your math menu. And if you go to probability, then you will choose number 3, I believe, is in combination of r. And therefore, that's how you can do it on a graphics calculator to complete combinations. Our homework will probably be 2 through 28 even on those pages, so you can keep track of that so you know it. Finally, the last thing you'll do is arithmetic with combinations, where they start mixing combinations and problems. They'll do something like 1 minus a combination of 5 choose 3, so that's 1 minus 5 factorial over 3 factorial 2 factorial, which is 5 times 4 over 2 times 1 for that portion, so it's 1 minus 10 or negative 9. And those are the kinds of problems where you're just learning how to work with this formula. Do them by hand as I've done here, and then use the calculator to help you. Okay, that's it.